Hello, my name is Beatty Bedell Estrada, and today I'll be talking to you about the conversion between rectangular and polar coordinates. Now, for a little bit of background information, there's a difference between rectangular and polar coordinates. Rectangular coordinates are written in x, y, where the y determines how far it moves left or right in relations to the origin, which is at 0, 0, and the y determines how far it moves up or down based on the origin. Now, with polar coordinates, rather than specifying where it needs to be moved, left or right or up or down, it is all based on two things: the distance it is from the origin to the point, and the angle it makes in relation to the x-axis in the form of 0 degrees up to the coordinate. So before looking at a couple of examples, we're going to be looking at the formulas first that would get us from one notation to the other, starting with r, which again is the distance from the coordinate point to the origin. And by doing this, we would use the Pythagorean theorem, which squares the horizontal leg of the slope and adds it with the vertical leg being squared as well. And to find the legitimate radius or distance, it would have to be squared. Also, we already know that the x is related to cosine, since cosine's formula is adjacent over hypotenuse, and that is the vertical leg that is adjacent to the angle. And the y is related to sine, since sine's formula is opposite over hypotenuse. And as you can see, the y, or the vertical leg of the slope, is opposite to the angle. And the last two formulas are used when the angle is not given. So we use tangent to find the ratio between the x and y value when they're given. So let's look at our first example for transferring from rectangular to polar coordinate, which says convert the rectangular coordinate -6, -6 to polar form. So let's have it written here. -6, -6 to polar form, which is equal to radius or magnitude, comma, angle, which can be written in angle form or in radian form. Now let's look at the coordinate. Both of them, both the x and the y, are negative. So let's think about this in terms of quadrants and its signs. So as you can see, we have the different signs here for each quadrant. And because they're both negative, you can see how the angles have to correspond to the third quadrant. So then you have to ask yourself, well, what angles are in that quadrant? So we have 210 degrees, 225, and 240. Now then, let's think in terms of the coordinates in the unit circle. Well, 225, both x and y, are identical, not counting the signs, but rather the numbers. And because both the x and the y have 6, we can say that the angle is 225, or in radians, 5 pi over 4. There you go. So now that we have the angle, check here. Now you have to find the magnitude, or the radius. So formula used for the magnitude, it would be R equals square root of x squared plus y squared. So we plug in the x, so negative 6 squared plus negative 6 squared under the radical. And of course, a negative that's always being squared will be a positive, so it would be 36 plus 36 inside of the radical. Now 36 is equal to 6. So it would be 6 times the square root of 2. So the answer in polar form, which is again r comma and the angle, would be 6 square root of 2 comma 225 degrees, or the same thing but with only 5 pi over 4. And there you go, that's the answer. Now let's look at a different example where we're now going to change polar form to rectangular form, and we're trying to convert 2 comma negative pi over 6 to rectangular form. Now let me write 2 comma negative pi over 6. We're going to convert it to rectangular form, which is x comma y, and x comma y. So the first thing that must be noticed is that we cannot let the negative pi over 6 stay there, so we have to make it positive. So we're going to go backwards, starting from 2 pi and subtracting negative 6, pi over 6. So, of course, to make it easy, we would change the 2 to 12 pi over 6 minus pi over 6, which gives us 11 pi over 6. Or, in angle form, it would be 330 degrees. 330 degrees, there you go. So, now we have the legitimate angle, and we can rewrite it back to polar form, but with a positive angle. So we have 2 comma 11 pi over 6, and the formula that we're going to be using now would, well, there's actually 2. We're going to convert this to the x and y value for our rectangular coordinate, and for the x it would be r cosine theta, and y would be r sine theta. And the r again is the 2, which represents the radius or the magnitude. And we can write it all at once to make it look like we're solving for a real coordinate. So we plug in the 2, cosine, and then the angle, I already said, was 11 pi over 6, comma, again 2, sine, then 11 pi over 6. So now we have to look back at the angle, which is 11 pi over 6, and we have to look at its coordinate, which is square root of 3 over 2 comma negative pi over 2. Whoops, forgot the negative. There you go. So I go back to the problem and I plug in the 3 square root of 3 over 2. And then here, along with the sine, I put in the negative 1/2. So we can cancel both the 2's out from the numerator and denominator, which leaves us with a square root of 3. And then we do the same, which leaves us with negative 1. There you go, that's the answer to rectangular form. Here I'm going to go box it to see it. Boom. There you go. Thank you for watching and referring to my video to help you all with polar and rectangular coordinates and the conversions with it. I had fun. I hope you enjoyed. Have a nice day, and I hope you come back.